once you've ascertained what that ratio equates to, then all you have to do is combine what you know it starts with, which again we discussed is 11, plus that value that we found is the ratio 0.87, and combine those, and that's going to be 11.87, which is going to be the approximate value of the square root here. And indeed, you can go to a calculator and take 11.87 and square it, and when we take 11.87 and square it, the result is 140.8969. That is very close to 141, so that is a good approximation. And we'll continue to practice that here when we go down to the check it out examples. That is a new concept for most of us, so probably a good thing to review again here, which we will do again in the check it out examples. Let's go ahead and take a look at question number 4 here. Number 4 is asking me to use a calculator to find the square root of 600, and we're asked to round to the nearest tenth here. So again, this is just me practicing using a calculator. You do have a square root button on most calculators. As you've heard me say in other presentations, if you do not have a square root button, the other option there is to use the power key and use 0.5 as the power. 0.5 as a power, or as an exponent rather, is equivalent to taking the square root. So if I put in 600 to the 0.5 power, it's going to be the same as me taking the square root of 600. I do that and I get 24.494, 89743, rounded off to the nearest tenth by the directions, 24.5. That's probably the type of question you will enjoy on the homework tonight because it is fairly simple, doesn't require much calculation at all, just requires us to use a calculator, not any real serious calculation on our behalf. All right, so let's go ahead and take a look at the concluding examples here. Number 1 is asking me to name what two consecutive integers the square root is between, and as you can see, they're talking about the square root of 80 there. So this would be a good time to recall that list that we were working with earlier. I'll give you some of the nearby surrounding ones. When we got to 7 squared, the result was 49. 8 squared, the result was 64. 9 squared, the result is 81, and at this point I can go ahead and stop because as you can see I've got the number that is closest to 80 on the low side, the number that is closest to 80 on the large side in terms of the perfect square roots. 80 is going to fit in between that 64 and 81 and obviously be a lot closer to 81 than it is 64. So since we're talking about what two integers that is between though, square root of 64 is 8, square root of 81 is 9, so the value is somewhere between 8 and 9. Number 2, you want to build a fence around a square garden that is 250 square feet. Calculate the length of one side of the garden and the total length of the fence to the nearest tenth. So we have a square garden here. This is a lot like a question we had earlier, and we're told that the area of the garden is 250 square feet. And we're supposed to figure out what the length of one side of the garden is and the total length of the fence that's going to be around that garden. Again, length times width is how we find the area, but in a square, the length and the width are identical. So it's really what number do I square that makes 250 here. So we're going to go ahead and work through that list using that same technique we just employed in question number 1 to find what the surrounding integers are for 250. So if we talk about 20 squared is 400. That's going to be way too big, so that's not even going to be a surrounding thing that we'd want to talk about. 15 squared, that's another one hopefully you know. 15 squared is 225. That's not too far off, so 15 squared is something we might end up working with here. 16, when I take 16 and square it, which is the next value, 16 squared is going to equate to 256. Well, that worked out pretty well because I found the nearest number that was below and the nearest number that was above. So 250 is going to fit right into here. So my answer is somewhere between 15 and 16. Remember, though, they're asking me to go to the nearest tenth, so we're going to have to keep working here. We can do like the squeeze method and go halfway here. So we're going to go to 15.5, which is halfway between 15 and 16 first. Well, when I take 15.5 and square it, the result is 240.25. I'm not particularly all that close right now there, so I'm going to have to go to something bigger. Remember, if I test a smaller number, the result will also be smaller. That's probably not going to work for me. So I want to test something bigger. Since we're only going out to the tens place, if we go up, we really only need to work with numbers that go in the tens place. So let's go up to 15.7. When I take 15.7 and square it, the result is 246.49. I've gotten closer there with 15.7 squared. And I'll go ahead and write that one down for you. That's closer, not exactly 250, but we're not too far off there. When I take 15.8 and square it, again, I'm going to go up again since I'm still a little bit too small there. 15.8 squared is 249.64. And obviously, that's very, very close to 250. So the only other thing we could test here and see if it gets closer would be 15.9. Obviously, if I go up to the next tenth, I'm at 16, and we already know that 16 isn't going to get any closer because that's 256. When I take 15.9 and square it, the result is 252.81. Well, not only have I gotten bigger, but I'm now 2.81 units away, whereas a moment ago, I was just about 4/10 away. So this is as close as I can get, so the length of the side of the square is going to be about 15.8 feet. Then they're asking me to find the length of the fence. Well, if there's a fence on each side, I'm taking that distance that I just found and multiplying by 4, and that's how they come up with the 63.2 feet.